Okay, in this lesson we're going to have a look at Unit 4, Chapter 4, Trigonometry and the Unit Circle. We're going to look specifically at solving trigonometric equations, and we're going to be looking at solving fairly simple trigonometric equations first. Okay, introduction to trigonometric equations focuses on algebraically solving first degree and second degree trigonometric equations in radians and in degrees. And again, we'll just do some simple ones in this lesson. We'll do the more complicated ones in the next lessons. Okay, let's start with solving a couple of very simple trigonometric equations. 3 cosecant x subtract 6 equals 0, and we'll look for our answers between 0 and 360. So I'm going to solve this for cosecant x. So I get 3 cosecant x is equal to 6. So of course, cosecant x will equal 6 divided by 3. So cosecant x is equal to 2. If cosecant x is equal to 2, I can rewrite cosecant as 1 over sine. So I get 1 over sine x is equal to 2. If I take the reciprocal of both sides, I get sine x is equal to 1 over 2. So we just need to consider where is sine x equal to 1 over 2. Now again, we need to remember our CAS rule when doing this. We need to remember that sine is positive 1/2 in 2 places. Sine is positive in quadrant 1 and also in quadrant 2. So sine is 1/2 being the second quadrant of my point. If the point is √3 over 2.5, you should recognize that point has a reference angle of 30 degrees. In both cases here, the reference angle is 30. So we're looking for the value of theta between 0 and 360, where the sine of the angle is equal to 1/2. Theta 1 is simply going to be 30 degrees, which is right here. There's theta 1. And theta 2, of course, is going to be this angle right here, which is going to be 150 degrees. There are my two values of theta, where sine of the angle is equal to the sine of the angle equals 1/2. And again, notice the two answers are between 0 and 360 as we expected, and it's in degrees. So I'm going to look at B, tan x plus 1 equals 0, between negative 2 pi and 2 pi. So in this case, I'm going to again solve the equation for tan x first. So I get tan x equals negative 1/2. Now where is tan x equal to negative 1/2? Well, let's consider where tan is negative first of all. Again, using our CAS rule, tan will be negative in quadrants. Tan is negative in what quadrants? Tan is negative in quadrants 2 and quadrants 4. There's where tan is negative. Now we need to think about what will the value of x be for tan x be negative 1. And if you remember your points, and these being special angles, we should remember that if I got the point √2 over 2 and √2 over 2, well in this quadrant of course x is positive, y is negative, you should recognize tan being sine x over cosine x. If I divide sine x by cosine x, I'll get a negative √2 over 2 divided by √2 over 2, which is equal to negative 1. So when I have a point at √2 over 2 and negative √2 over 2, or up in this quadrant, negative √2 over 2 and √2 over 2, I will still get negative 1. My reference angle you should recognize here now is pi over 4. Pi over 4 is the reference angle when tan x equals negative 1. I'm looking for all the answers between negative pi, 2 pi, and 2 pi. What I normally do with domains such as this, I break them into 2 separate regions because we always measure theta from the positive x-axis. So I would consider this as a domain between 0 and 2 pi and between 0 and negative 2 pi. So let's again look at my 2 regions here. Theta here is between 0 and 2 pi and between negative 2 pi and 0. In this region, let's pop my terminal arms in again. Terminal arms located here. You can see that I will have 4 answers. I will have 2 answers as I rotate once in the positive direction, and I'll have 2 answers as I rotate once in the negative direction. Let's list the answers. Theta 1 will be, and remember your reference angle is pi over 4. So your first angle is going to be 3 pi over 4, which is this angle right here. It's 1 pi over 4 less than 4 pi over 4. And theta 2 is going to be 7 pi over 4, which is this angle right here. 7 pi over 4, because we need to think that this here now is 8 pi over 4, and I'm 1 pi over 4 less than that, so that's 7 pi over 4. So there's 2 answers. Now in the negative direction, I will have an answer at negative pi over 4, and I'll also have an answer at this rotation. This is negative 4 pi over 4. So of course the other answer will be negative 5 pi over 4. I'm 1 pi over 4 beyond negative 4 pi over 4. So that's negative 5 pi over 4. So my 4 answers are 3 pi over 4, 7 pi over 4, negative 5 pi over 4, and negative pi over 4. There are the 4 values of x when tan x is equal to negative 1. So look at another example. This example is looking for the general solution this time to the equation sine squared x subtract 1 equals 0 over the real numbers of x is measured in radians. Again, x is measured in radians. Looking for all the answers now where sine squared x subtract 1 equals 0. So I get sine squared x subtract 1 equals 0. So sine squared x is equal to 1. If I solve for sine x, I get sine x equals plus or minus the root of 1. So of course, sine x is equal to plus or minus 1. We need to consider where sine x is both positive 1 and negative 1. This will involve quadrantal angles. So let's think about the points where sine x is positive 1 and sine x equals negative 1. Let's think about our points. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Where is sine x equal to positive 1 and negative 1? Sine, remember, is your second coordinate, so it's in these 2 locations. If I want to write the general solution, I'm going to write this. X is equal to, now again our answer is going to be in radian measure. There's one answer, which is pi over 2. And another answer would be at 3 pi over 2. But remember, you're looking for the general solution. The general solution means all angles that satisfy that equation. All the angles that satisfy that equation will be coterminal with these angles as well. So how do I write angles that are coterminal with pi over 2? I write pi over 2 plus 2 pi n, where n is the number of I. This will include all the angles that are coterminal with pi over 2. And of course, all the angles that are coterminal with 3 pi over 2, including 3 pi over 2, is 2 pi n, where n is the number of I here as well. This is one way to write my solution. There is another way. I can actually combine these 2 solutions into a single solution. And the reason why I can do that is because this answer and this answer, pi over 2 and 3 pi over 2, are separated by pi. Pi over 2 plus pi will give me 3 pi over 2. If I add pi again, I'll get another answer. If I continue to add pi, I'll get the next answer. Add pi, add pi, add pi. If I continue to add pi to pi over 2, I will continue to get answers. And the same is true that if I started with pi over 2 and I subtracted pi, I would get an answer. Subtract pi, I would get an answer. And so on. So I can actually combine these 2 into a single answer and write x equals, starting with pi over 2, plus pi n, where n is the number of I. This answer here will include all the answers that you get from these 2 separate sets right here. And again, it's the reason being is because pi over 2 and 3 pi over 2 are separated by pi. So if I keep adding pi, I will continue to get answers. If I subtract pi, I will continue to get answers as well. So if I start with pi over 2, I add pi or subtract pi, I will get all the answers that you would see up here. Example 3. Solve for theta. Cotan theta subtract 1 equals 0. Again, notice your restricted domain between negative 2 pi and 2 pi. So we're going to do cotan theta equals a positive 1. Oops. Let me fix that. It's a pretty big 1 there. Cotan theta equals a positive 1. Cotan is 1 over tan. If I take the reciprocal of both sides, I get tan theta equals positive 1. Now, where is tan theta equal to positive 1? Very similar to the question we did earlier. Tan theta is equal to positive 1 if we use our CAS rule in these two quadrants. And again, if we think about tan being positive 1, that will occur at a special angle if this is root 2 over 2 and root 2 over 2. Sine divided by cosine is 1. Tan is sine over cosine. There's the sine of theta. There's the cosine of theta. If I took sine divided by cosine, I would get 1, which is tan. My reference angle again is pi over 4 and pi over 4. Now this time again, I'm looking for answers between negative 2 pi and 2 pi. So again, I would break that into two separate regions. Let's do that. Again, let's draw the terminal arms in these two regions. A second here, we change the color for my terminal arms. There and there. And I'm rotating once in the positive direction. I'm rotating once in the negative direction. That will include this restricted domain. If I rotate once in the positive direction, I get pi over 4 as an answer. And I will get 5 pi over 4 as an answer. And again, recognize where I'm getting the two answers from. One answer is there, pi over 4. The next answer is right there. That's 5 pi over 4. Remember that this is 4 pi over 4 here, which is pi. So I'm 1 pi over 4 beyond that. If I rotate in the negative direction, this is negative 4 pi over 4. So one answer is right here, which is 1 pi over 4 less than 4 pi over 4, which is a negative 3 pi over 4. And the next answer will be right there, which is 1 pi over 4 less than negative 8 pi over 4, which is negative 7 pi over 4. So you can see my four answers will be pi over 4, 5 pi over 4, negative 3 pi over 4, and negative 7 pi over 4. Answer there is A. And I think I have one more example left, and here it is here. Cosecant squared theta equals 4. Solve it between 0 and 360. Okay. Cosecant squared theta is equal to 4. Cosecant squared, if I solve that for cosecant theta, I get plus or minus the square root of 4. Don't forget the plus or minus is critical in this question. So I get cosecant theta equals plus or minus 2. Cosecant is 1 over sine. So 1 over sine is equal to plus or minus 2. If I take the reciprocal of both sides, I get sine theta equals plus or minus 1/2. Now I need to consider where sine is both positive 1/2 and negative 1/2. So if you think about that using the CAS rule, sine is positive in 2 quadrants and is negative in 2 quadrants. So I actually have terminal arms in all 4 quadrants here. So I'll just draw terminal arms in all 4 quadrants. Doesn't matter where I draw them. But sine being 1/2 means my second coordinate got to be 1/2 in all cases. So if my second coordinate is 1/2, you should recognize the first coordinate is 3 over 2. 3 over 2 has a reference angle of 30 degrees. So all of these have reference angles of 30 degrees. So let's look for our 4 answers. Between 0 and 360, that's one complete rotation all the way around, I will have 4 answers. 30 degrees will be an answer. That's right there. My next answer is right here. If I rotate in the positive direction, that's 180 minus 30, which is 150. If I continue to rotate, That's another terminal arm right here. So that's 180 plus 30, which is 210. And finally, my last one is going to be 360 minus 30, which is 330. There are my four values for x, or theta in this case. 30 plus 30, 150, 210, and 330 is correct answer is A. So there are some examples of solving simple trig equations. Key ideas. To solve a trig equation algebraically, you can use the same techniques that you use in solving linear and quadratic equations. When you arrive at sine theta equals A, or cosine theta equals A, or tan theta equals A, then you use a unit circle for exact values of theta, and the inverse trig functions key on the calculator for approximate measures. And we use reference angles to find solutions in other quadrants, and we did a lot of that in this lesson. To solve a trigonometric equation involving cosecant, secant, or cotan, you may need to work with related reciprocal values, which we did. To determine a general solution, where the domain is real numbers, you find the solution in one positive rotation. Then we use the concept of coterminal angles to write an expression that identifies all possible measures, and we did an example of that as well. And that ends this lesson.